So welcome back, guys. Today we're going to be looking at cabbage juice, specifically red cabbage juice, and how it works as a pH indicator to determine if a solution is a acid or a base.
Awesome. So first thing we're going to do is we're going to go ahead and take some of our cabbage, throw it in a blender with some water in it, and we're just going to go ahead and blend it up for you guys.
So that should be a deep purple color, and we'll pour it into that beaker.
So we're going to add a bunch of different chemicals. First thing we're going to add is some lemon juice. We're also going to add some baking soda. We have ammonia. We have some good old-fashioned hydrochloric acid.
So the pH scale goes from 1 to 14, with 1 to 6 being acidic solutions, 1 being the most acidic on that scale. 7 is a neutral pH, so you have basically an even amount of acid and base properties. And then from 8 to 14 is the basic side of the spectrum, so with 14 being the most basic, and 8 being the least basic.
Now, where would water sit on that scale?
So pure water should be about 7, right in the middle on that
Right in the
pH
middle.
scale. Yep.
So it's neither basic nor acidic?
Yep, and that's what we actually have here with our red cabbage juice. So this is just cabbage juice and water. You can see it's a pretty deep purple color, which is roughly 7 on the pH scale.
Yeah.
Now, if we can use this as a sort of natural pH indicator to determine if a solution is an acid or a base. If it's an acid, introducing this solution to that mixture should change the color to a more red, I believe. And then if it's a base, it'll become blue, which is why it's purple to start with.
Perfect. First thing we're going to do is we're going to pour out some lemon juice.
And let's see what happens.
Perfect.
Yep, so as you can see, the purple cabbage juice turned red, indicating that this is a pretty acidic solution.
Next, we're going to add some baking soda. That seems about enough.
All right, here comes some cabbage juice. And sure enough, it's that bluish color. It's definitely a basic solution.
Next, we're going to add some ammonia. Now, what do you think ammonia is going to be?
I'm going to go with blue here, considering it's a pretty strong base.
Yeah. Now, it's clear right now, but let's watch what color it turns.
Oh, it's actually
Ooh,
green.
yeah.
That's impressive.
Pretty impressive, huh?
Yeah.
All right. And then we got one more. We got hydrochloric acid, which the name implies itself, but we're going to go ahead and see.
Let me actually pour this first, just to be safe.
Yes.
So I'll just dump the rest of our cabbage juice in there. You can see it's a deep purple color.
That was quick.
It's a deep red. Definitely very acidic solution.
All right.
We can actually see more of how this works by combining some of these together. So for example, we can take our ammonia, I guess, a very basic solution, and pour it into the acidic lemon juice, and hopefully it'll sort of go back to a purplish color.
Yeah.
Let's see. Just kidding, it's pretty basic.
Yeah, we turned it pretty basic.
Yeah.
Actually, so as you can see, it actually turned back to lemon juice.
Oh yeah.
So
It's pretty clear now.
yeah, it's pretty clear.
Yeah.
So why don't we mix, do you want to mix the baking soda and hydrochloric acid?
Sure, just a very little amount should suffice. It's got that deep purple color.
I'll show you guys at the bottom. You can see
Yeah.
it's still pretty acidic. Let's add more cabbage. Let's add more cabbage.
So we're just trying to dilute the hydrochloric acid. It's still going to be a strong acid.
It's
And,
very strong acid.
Maybe add some baking soda or ammonia.
Let's add some.
Okay. You can see how it turns purple in the gas when it hits. There
Oh,
we
see,
go.
look, there you go. Yeah.
So now it's becoming closer to neutral on the pH scale.
Look at that. That's all we have for you today. Make sure to check back next week for more awesome experiments with Expulsion Science.